Okay, so what we've got here is we've got a situation that we're trying to analyze. Our goal is to eventually be able to answer the question, what is the secant of 90 minus theta degrees? And we'll have a different triangle. We'll have a triangle to look at for this. What we're going to do, though, is we're going to start by looking at a situation that's a little bit more general. This time, instead of thinking about having specific angles theta and something else, we're just going to talk about having angles alpha and beta. So here's a right triangle. Obviously, it's a right triangle, you can tell, because of that little guy right there. What we want to do is just calculate the sine for each angle. We're going to do alpha first. We're going to stick to the three simple trig functions. So first of all, the sine of alpha. We start here on alpha. Oops. Still trying to figure this thing out. We start here on alpha, and we go, okay, what is the sine? Well, let's look. The sine of alpha is going to be the opposite over the hypotenuse. So that's just what it is, SOHCAHTOA. So, sine of alpha is A over C. Again, in the back of your head, you're thinking, SOHCAHTOA. Okay, so that's sine. Cosine. So cosine alpha, again, we're relative to this angle. So the cosine is going to be the adjacent over the hypotenuse. So B over C. And lastly, the tangent. Again, we're going from this little angle. Tangent is going to be the opposite over the adjacent. So we're going to have A over B. Okay, now, we've done that, but now let's go a different way. Let's look at the sine, cosine, tangent for beta. All that means is we're just going to use a different angle to start off with. Like we're referencing from this angle. So we start there. We go, okay, what's the sine of beta? Well, now it's going to be the opposite over the hypotenuse. Because it's still SOHCAHTOA, we're just using a different angle. So that means the sine is going to be B over C. Well, what about the cosine? Adjacent over hypotenuse. A over C. Oops, okay, I can't do that in that order. Maybe I can. Trying to figure this out as I go. Yeah. Sorry. That makes it, it's going to be, sorry, it's A over C. Okay, and then lastly, the tangent of beta, opposite over adjacent, means it's going to be B over A. And okay, what have we done? We've calculated the sine, cosine, tangent for the two angles. There are only two acute angles here, so we've now got both of them covered. What you might notice is that there's some connections here. Like, we don't have to necessarily think about it too much, but you might notice that there's a connection between these two guys. If you notice, the sine of beta and the cosine of alpha are completely equal to each other. And second, the cosine of beta and the sine of alpha are equal to each other. So, kind of interesting. I wonder why that is. Well, now let's go look. Once I figure out how to move to the next page. I did it. Nice. Okay. So now that I got it, let's look at that same triangle again. This time, though, instead of calling it alpha and beta, I'm going to call it theta. Right there. We'll still have the same sides. We'll go A, B, and C. And now we're going to look at the two different angles that we have. We're going to calculate the sine of theta, the cosine of theta, and the tangent of theta. And then next we'll do the other parts. So first of all, what are they? Well, just once again, we can do this really quickly. Sine is opposite over hypotenuse. This is A over C. The cosine is adjacent over hypotenuse. It's going to be B over C. And our tangent is opposite over adjacent. A over B. Okay, so what has that done? Well, not much. What I want to emphasize, though, now, is we can actually find the same things for the other angle, just like we did before. If you recall, on the last slide, we went up here to B, or to beta, and we calculated the sine, cosine, tangent. Well, we're going to do the same thing down here. In this example, the only difference is we're not going to call it beta. What we're going to do is call it what it really is. So think about the measurements here. This is 90 degrees. This is theta degrees. This guy, in order for this whole thing to add up to 180, this has to be 90 minus theta degrees. So what does that do? Well, now we can calculate some other things that we haven't been asked for before. We can find the sine of 90 minus theta degrees. We can find the cosine of 90 minus theta degrees, and we can find the tangent of 90 minus theta degrees. How do we do that? Well, we can once again just look at our triangle. Here's our angle. I'll use, I guess, light green this time. Here's our angle. So there's 90 minus theta. The sine, opposite over hypotenuse. It's going to be b over c. And notice once again, sine of 90 minus theta and cosine of theta, they're right equal to each other. Okay, what about cosine? There is my angle, so 90 minus theta, adjacent over hypotenuse. It's going to be a over c. Just fix this a little bit. There we go. And lastly, our tangent, going back to our angle once again, opposite over adjacent, it's going to be b over a. And so what do we do? Well, the reality is we didn't do anything different. We didn't do anything new at all. All we did was recognize that if this is theta, right here, then this angle has to be 90 minus theta, because that's the only way we can get this whole thing to add up to 180. 80 degrees equals our right angle, which is 90 degrees, right here, plus our angle theta degrees, which is right here, plus our last angle, which in order for this whole statement to be true, has to be 90 minus theta. That way we have 90 plus 90 is 180, plus theta minus theta is 180. Our equation's true. So that's the only way it has to be. This has to be our angle. Like this guy has to be 90 minus theta. Okay, now that we're here, well, we just calculated just like we would before. It's identical to what we did for angle beta right here. We went, okay, opposite over hypotenuse, for example. Or we did adjacent over hypotenuse, whatever the case may be. We just ran right through it, no issues whatsoever. Okay, so that brings us to the problem here. The home stretch. What do we do for situations? What do we do for a situation where, let's say, they give us our triangle. It's okay, there's theta. And then let's go, I don't know, let's go K, J, M. Let's pick some different letters. And now let's say, how do I find the secant of 90 minus theta degrees? Because that was our original goal, was answering this question. Well, first, we do need to recognize that secant of anything, and actually I'm not going to use theta, that would be confusing. I'm going to say secant of an angle is equal to 1 divided by the cosine of that angle. It's just the reciprocal relationship there. So what we really want to find is what is 1 over the cosine of 90 minus theta. Okay, no issues so far. Good. You couldn't tell me if you had an issue. That's okay. Okay, so now what do? We need to find the cosine of 90 minus theta. Well, first, where is that? 90 minus theta is right here. This angle is 90 minus theta. Now then, there you can just think about it as like b. We could just call this angle b if we wanted to, but we're not going to have to. We're just saying relative to this angle, right here, what is the cosine? Well, okay, let's look. Here's my angle. My cosine is adjacent over hypotenuse. Adjacent, well, first of all, it's 1 over. Let me actually go back here. I think I'll make this color look better. Okay, so my angle is right here. And okay, what is my cosine? Adjacent over hypotenuse. So we're still going to have the 1 over, because we still had that, but the cosine is adjacent over hypotenuse. What does that leave me with for my answer? Well, this says 1 over, it just says flip it, m over k. And there is the secant of 90 minus theta. 90 minus theta is just another angle. Ran out of space. Angle. And there we go. So again, just to reference it all, what did we do here? We started by looking at general triangle and labeling those two angles so that we could talk about it. And we could say, oh, well look, we just have two angles here. We can find their sines and cosines totally fine. In the second one, we went through and we said, okay, well what is that angle really? Well, if we call this one theta, we can call this one 90 minus theta so that the equation for how many degrees there are in a triangle holds up. So lovely. Finally, we went through and said, okay, well then if we need to find something like the secant of 90 minus theta, how do we do that? Quickly, by labeling it as 90 minus theta, identifying all the pieces that are needed there, including that cosine, and then actually just calculating the cosine relative to that angle. Adjacent over hypotenuse, bam, there's our secant. Hope that helped.